All right, guys. So, as a lot of you probably saw or remember in that complex number video that you watched, the complex number plane is kind of going to look a lot like your x and y axis. Okay, but the way they kind of showed it is they kind of showed it running perpendicular to the real number plane. Okay, like coming up out of the paper. If you remember that from the video, the complex number plane is kind of running perpendicular to the real number plane. Okay, but when you go to do that, obviously you don't have three-dimensional paper in front of you. Okay, you're sitting on flat two-dimensional paper. All right, so you can just work with what looks like a normal x and y axis. However, make sure we just label it the real part and the imaginary part. Okay. Remember from yesterday, all complex numbers look something like this. A plus bi. Okay? So it's really pretty basic. One thing you'll be asked to do is simply to graph numbers on the complex number plane. Okay? So for instance, if I asked you to graph the number 3 minus 2i. Okay? It's really pretty straightforward. 3 is the real part. So you'll go 3 in the real direction, and then you'll go negative 2i in the imaginary direction, and this would be the location of the number 3 minus 2i. It looks a lot like plotting the point 3 comma negative 2, right? Okay, it's just in the complex number plane. Like if you recall from the video, remember, is kind of running perpendicular to the real number plane. It's like it's coming up out of the paper, basically, or above and below. Okay, but I just want you to be familiar with graphing numbers in the complex number plane. All right? I'll do another one just to be certain you got it. How about negative 3 minus 4i? So where am I going to go to graph that point?
Negative 3, negative 4.
3 to the left, so I'm going negative 3 in the real direction, and then
4.
down 4. Okay? So this would be the coordinate, or excuse me, this would be the complex number, negative 3 minus 4i. This was the complex number, 3 minus 2i. Okay? Any questions on graphing complex numbers? Okay? Like half of the problems on the worksheet are that. It won't take you long at all. Okay? Now, the next thing you will be asked to do, actually it's what comes first on the worksheet, so I don't quite understand that, but it makes more sense to see this first as opposed to do what's next. You will see problems that look something like this. Okay? What do those bars mean to you? Absolute value, yeah, very good. Okay? So, actually, sometimes they even call this the modulus of a complex number, but the directions on your worksheet will just say find the absolute value of the complex number. Okay? Now, it's not quite as easy as you would think. If you go back to whenever you first learned absolute value, so I don't know, 7th grade, 8th grade, whatever it might be, okay, what was the definition for absolute value? The distance from 0 on a number line, right? The distance from 0 on a number line, okay? Well, the only difference in the complex number plane is this. When I ask you for the absolute value of a complex number, I want to know how far is that number from the origin. Not just from 0, how far is that number from the origin? Okay? So just like how far is that from 0 on a number line, how far is this number away from the origin on a complex number plane? Okay? Well, let's think about where the origin is, and let's think about where this complex number is located. Okay? We graphed it on the previous page, and I'll do it again one more time here. Negative 3 minus 4i is located right here. I want to know how far is this complex number from the origin. So I want to know how far away is this complex number from the origin. What are we going to do to figure that out? Pythagorean's theorem. Very good. okay? You can't count diagonally, guys. That doesn't work that way, okay? You can only count horizontally and vertically, okay? So what you do is from wherever your complex number is, okay, make a right triangle. We can count up and down. So that side of the right triangle is 4 units long. This side of the right triangle is 3 units long. And in order for us to figure out the hypotenuse, which is what we want to know, right? We want to know how far away are these two coordinates from one another. All you have to do is a squared plus b squared equals c squared. Okay, very good. Some of you remembered a 3, 4, 5 right triangle. That's awesome. Okay, some of you just know the answer is 5 already. Okay, for those of you that don't, all right, you would just set up 3 squared plus 4 squared equals c squared. Which, by the way, if you look at the complex number, do you think you'd have to draw the picture every single time? No, right? Isn't this number always going to be your real part? The absolute value of your real part, so 3 squared. And won't this coefficient on the I, won't that always be your b squared? So do you really have to draw the picture anytime? No, but if it helps you make sense, go for it. Okay? 3 squared is 9, 4 squared is 16. That would be 25. Square root both sides. Okay? So the absolute value of this complex number is 5, because that number is 5 units away from the origin on the complex number plane. Any questions on that? Don't give me decimals. You know, so if the radical doesn't come out to be a nice number, just give me simplest radical form. So like, 4 radical 2, 2 radical 5. Okay? That's really it. If you look at the link itself, if you want to do all 10, do all 10. If you got the hang of it after 4, don't waste your time. Okay? But these first 10 are just all finding the absolute value of those complex numbers. The next 1, 2, 3, 4, 5, 6 problems simply just ask you to graph each number in the complex number plane. So all you'll be doing is plotting that number, right? Plotting that point, in a sense. So that's those 6 problems. And then all they do on the last 6 is they switch it around. They plot the point for you. You tell me what number that is. Is that okay? Yeah. All right. So, do whatever you need to from this link, because there'll probably be one of each type of these on the quiz tomorrow. And then if you have any other questions from the last few days of class, the little bit tougher stuff, over the exponents or the adding, subtracting, multiplying, dividing, okay, that is your opportunity. If you have all of this done, plus that link done, or at least a healthy chunk of it done from each section, and you know what you're doing, I don't need to hold you here anymore, all right? You just show me that you have all that, and you're good to go.